talk about another concept or revisit. Remember in the beginning when we started discussing motion, we said all motion is relative. In fact, if an object is moving or not moving depends on where the observer is and what the observer is doing while he is observing. Is that right? In fact, it depends on the frame of reference of the observer. Well, let's spend some more time talking about that concept, relative velocity. All velocities are relative. It depends on the frame in which the measurement is being made. If you are driving in the positive x direction at 20 meters per second, a passenger sitting next to you will see you at rest, while a person standing on the roadside will measure your velocity as 20 meters per second I, because you're going in the positive x direction. Is that right? So you are in the car is moving due east towards the positive x direction with a velocity 20 meters per second. You look at your friend in the passenger seat and say, hey, you are at rest. But your friend standing outside looks at the passenger and say, the passenger in the car is moving in the x direction with a velocity 20 meters per second. Is that right? Yes. So the person outside will see the person in the car moving due east or in the positive x direction with a velocity 20 meters per second. A person in a car moving in the negative x direction. All right? Now you are in the car that goes east. Another car is going west in the opposite direction. A person in a car moving in the negative x direction at 15 meters per second will measure your velocity, and what will that velocity be? You see, that person will see you moving away from him at 35 meters per second. Have you understood that? The person in the second car is moving west and you are moving east. So the person in the car that is moving west will see you moving away from him at 20 plus 15, that is 35 meters per second. In fact, the distance between your car and his car is changing at the rate of 20 plus 15, 35 meters per second every second. And that is why we say the person in that car will measure your velocity as 35 meters per second I. Now that means when that person measures your velocity, that is measured relative to his frame of reference. Is that right? A person outside will measure your velocity at 20 meters per second I. That is from this frame of reference. A person in the other car that moving west will measure your velocity at 35 meters per second. And that measurement is made from the frame of reference of that second car. So, the velocity that you measure depends on the frame of reference from where the measurement is made. Yet, another person in a car traveling in the positive x direction. Suppose there is a third car that is passing you in the same direction, and he is moving at 25 meters per second. You see, your velocity is 20 meters per second I, and the car that is passing you is passing at 25 meters per second. Now tell me, if that person measures your velocity, what will be your velocity? In fact, every second you are moving 20 meter. Every second the other car is moving 25 meter. That means the distance between the two cars is increasing every second by 5 meters. That means the velocity of your car measured from the passing car will be 5 meters per second in the opposite direction. Your car will appear to be moving backward from the car that is passing you. I hope you understand that. So another person in a car traveling in the positive x direction at 25 meters per second will measure your velocity as negative 5 meters per second I. Now, when I was discussing the relative motion, I showed you an animation. Let's go back and look at that animation one more time to understand relative motion and frame of reference. Now, what is the frame of reference now? The frame of reference is the ground. Now, let's give some values here. When you are standing on the ground, let's say the man is walking in the x direction with a velocity 1 meter per second. Is it okay? We will just assume that. So let me write that down here. So we say velocity of man is 1 meter per second. Let's say the velocity of the river is 3 meters per second, and velocity of the boat is 5 meters per second. We're just assuming these values. Okay. Alright, let me write that again. Now, what happens when you move the reference frame? When you move from the ground to the river, you can see the river is at rest. The river is the frame of reference. So, what we did here, what was the velocity of the river? We said the river is flowing down with a velocity 2 meters per second when you observe from the ground. And now, when you are in the river seems to be at rest. That means, in order to bring the river to rest, we applied a velocity 2 meters per second to the river in the opposite direction. You see? Originally, we saw the river moving down at 2 meters per second. Now, when you are in the river, you brought the river to a stop. That means you applied a velocity of 2 meters per second in the opposite direction. And now, the velocity of every object from the river will be having the same effect. Apply everything else a velocity 2 meters per second in the opposite direction. Now look at this. The man originally we said was moving 1 meter per second to the right. And now you see him moving 1 meter per second to the left. That means when you brought the river to a stop by applying an equal and opposite velocity of the river, 2 meters per second to the left, you apply that velocity to every object. When you apply that velocity to the man is now going 1 minus 2, that is negative 1 meter per second to the left. And from the ground you saw the boat was moving at 5 meters per second. When you came down to the river, what is the velocity of the boat measured from the river? You see, to bring the river to a stop, you applied an equal and opposite velocity to the river. And you need to apply that velocity to every other object. So apply that negative 2 velocity to the boat. The boat now has a velocity 5 meter per second down and negative 2 meter per second up, and the net velocity is 3 meter per second. So when you observe it from the river, the boat will appear to be moving with a velocity of 3 meter per second. And watch my language. The velocity of the boat measured from the river is 3 meter per second, 5 minus 2. And we call it the velocity of the boat with respect to the river. The velocity of the boat with respect to the ground is 5 meter per second. The velocity of the man with respect to the ground is 1 meter per second I, and the velocity of the man with respect to the river is negative 1 meter per second I. And now, if I want to measure the velocities of all these things from the boat, what do? I bring the boat to a stop. You know, when I observe it from outside, alright, let's go outside again. When I observe from outside, the velocity of the boat is 5 meter per second. And to bring it to rest, what do? Apply a negative 5 meter per second to the boat. Now the boat will come to a stop. Now to find the velocity of every other object from the boat, you have to apply that negative 5 meter per second to everything. That means, tell me, what will be the velocity of the man if you measure it from the boat? Now, first of all, bring the boat to a stop by doing what? By applying a velocity, applying its velocity equal and opposite. Negative 5 meter per second to the left. Boat comes to a stop. Apply the same velocity to the man, negative 5 meter per second. And now, the man has two velocities. His actual velocity 1 meter per second to the right, and now the imposed velocity negative 5 meter per second to the left. So when you measure it from the boat, he will appear to be going left at 4 meter per second. Alright, let's go to the boat and bring the boat to a stop. Look at this. When you measure the velocity of the boat, velocity of the man from the boat, he is rushing in the negative x direction at 4 meter per second. Is that right? So this is what we're going to do to find the relative velocity. We are finding the relative velocity of the man with respect to the boat. Right? Now, if I want to find the relative velocity of the boat with respect to the man, what do? I go and bring the man to a stop. Alright? Let's find the relative velocity of the boat with respect to the man. Alright? Now, tell me again. When we observe from outside, what is the velocity of the man? 1 meter per second I. What is the velocity of the boat? 5 meter per second I. Alright, now I want to find the relative velocity of the boat with respect to the man. That means the man is now the frame of reference. So what do? Bring the man to a stop by applying 1 meter per second in the opposite direction. That means you got to apply the same to the boat. The boat will now have a velocity 5 meter per second down and 1 meter per second up. So the man will measure the velocity of the boat as 5 minus 1, that is 4 meter per second I. There you are. Let's go and bring the man to a stop. There you are. We are now measuring the velocity of the boat. Well, I think I need to move it. Give me a second. I want the man to come